Good morning everyone, good evening or good afternoon whenever you are watching this video. Okay. So today we are going to talk about isometric process or isochoric process. Okay. Isochoric or isometric process are the same process. It's just a difference in the name. Okay. Iso means same and choric stands for volume. Okay. Choric you can say or metric, both stands for volume. So it's that thermodynamic process in which volume remains constant, right? So it's thermodynamic process in which volume remains constant. Okay. So if volume remains constant, if you remember Charles' law, right? Charles' law says that if volume remains constant, pressure is directly proportional to the temperature, right? Or you can see from ideal gas equation also. Okay, PV equals to nRT. Okay, so P I can write nR by V into T. Now number of moles is constant, R is constant, V is constant, right? So V is constant, R is my gas constant, so constant, and this number of moles is constant. So basically you can say P is some constant times T, or you can say P is proportional to T. Okay, or else you can say P by T is some constant value. Right? P by T is some constant value. Okay. So if I want to see the nature of the graph, how will my pressure versus volume graph will look like if I talk about isochoric or isometric process, right? Okay. So it's that process in which volume will not change. Volume has to remain constant. So if I see the nature of pressure versus volume graph, so P versus V graph, if pressure changes, my volume has to remain constant because it's an isochoric process, right? So my volume has to remain constant, so my graph will be somewhat like this. Okay. Okay, so you'll be seeing a straight line graph parallel to this pressure axis, right? So if I talk about slope of this graph, if you see this line is making angle 90 degree with this x-axis, so theta is 90 degree, right? So tan theta will give me slope of this graph, right? And so tan theta is 90 degree, so tan 90 degree, it's basically infinity. So slope of this graph is infinite. Okay. Okay. Okay, so now if I talk about first law of thermodynamics, right? If you want to understand, first law of thermodynamics says it says that heat given to a system will be reflected in change in internal energy and work done, right? So you'll be seeing Q given to a system is equal to change in internal energy plus work done, right? So Q is nothing but delta U plus work done. Work done you can write integral PdV, right? Since my volume is not changing, right? Volume is remaining constant. Volume is constant. So work done will be 0, right? So this entire value is going to remain 0, no change in volume. So you can say Q is equal to delta U. What does this actually mean? Means you are supplying heat to the system and that heat is completely utilized in changing internal energy. There is no work done at all, right? If you want to take a visualization of this, if you want to take the feel of it, you can think like this. Okay. Suppose I had a isochoric process. Suppose if I am going from state number 1, suppose you imagine there is a piston in which we have a n moles of gas. Okay. Pressure is P1, temperature is let's say T, and volume of this gas is let's say V. Okay. Temperature T1, volume V. Okay. Now you supply heat to this. Okay. That heat will be completely utilized in changing the internal energy. There won't be any change in the volume. There is no work done at all. Okay. Okay. So in second state of a gas, number of moles is going to remain constant. Pressure may change, pressure will change. Temperature is changing, but volume is remaining constant. There is no expansion of the gas or there is no compression of the gas. So there is no work done at all. Okay. Okay. So this is about isochoric or isometric process. Whatever heat you are supplying to the system, that is only reflected in change in internal energy, right? Because there is no change in the volume, so no work done. Okay. Okay, now we'll discuss cyclic process. Okay, so cyclic process, you can say it's a combination, it can be a combination of different thermodynamic process. So you can combine adiabatic, isothermal, isochoric process, all process together and make a cyclic process. But basic understanding, what actually you understand by cyclic process? Cycle, see, whenever there is a formation of cycle, cycle is always formed whenever my initial and final point becomes the same point. Right? So if my initial point, okay, initial point, suppose I am starting from A and I am going to B in a pressure versus volume graph, and again from B to A, I am forming a cycle. Can you see? This was my initial point. I started from A, I went to B, then back to A. So my initial and final point are same. So then this process is said to be a cyclic process. Clear? Okay. What else? So cyclic process, in a way you can define, okay, it can be a combination of different processes, okay, in which initial and final point you can say or state you can say are same, है ना? If अगर initial or final point are same, then you can say it is a cyclic process. Simple as it is. Okay. Now if I apply first law of thermodynamics, ठीक है? First law of thermodynamics क्या कहता है? What does it says? First law of thermodynamics says that heat given to a system, okay, will be utilized in doing some work and change in some internal energy, है ना? So it will do some work and there will be change in internal energy. Okay. Internal energy, if you remember, it's a state function, है ना? State function. State function मतलब क्या? What does it mean? Okay. It depends upon initial and final point. ठीक है? It doesn't depends upon the path through which it is taken. It depends upon initial and final point, है ना? Okay. Now if you see initial and final point are same. Suppose I started from A, I went to B, then back to A. Suppose temperature at point A was TA, temperature at point B was TP. So I started from A to B, then back to A. Means my initial temperature and final temperature are going to be same. Can I say? Yeah. So Q is work done plus delta U. Delta U can write final internal energy minus initial internal energy, and final internal energy you can write NF by 2 RT final, and initial you can write NF by 2 RT initial, right? Now initial temperature and final temperature are same, right? So this term will be 0, right? So basically you can say Q is equal to work done. Okay, so in a cyclic process, whatever heat is supplied to the system, okay, the heat is completely utilized in doing work. There is no change in internal energy at all. Okay, this is understandable from here. Let's explore it a little bit more, है ना? Okay, I'll erase this. Okay. Now cyclic process, you can have two types of cyclic process, huh? Because cycle you can go either in clockwise or anti-clockwise. So based on this, that we'll have two types of cyclic process. Okay. Okay. So suppose I'm starting from A, I'm going to B, then back to A. Okay. So I'm forming a cycle, and this sense is clockwise sense, right? Because hand of a clock moves in this direction, no? 12, 1, 2, 3, 4, right? So it's a clockwise. Clockwise. And we can also have anti-clockwise, pressure versus volume graph. Okay. So I'm going from B to A. Sorry, I'm going from A to B in this sense and back to A. Now I'm forming anti-clockwise, right? So this is anti-clockwise. Okay. Okay. Now since heat supply to a system will be completely used in doing work, so work done can be positive and work done can be negative, right? Okay. So if cycle is clockwise, okay, so work done will be positive. Okay. If cycle is clockwise, work done is negative if it is in anti-clockwise. We'll understand, we'll explore why I'm writing positive and negative. So if work done is positive, means all in all, okay, all in all, you can say work is done by the system. If I talk about net work done, okay, you can say net work is done by the system. If work done is negative, you can say net work is done on the system. Right? This is the convention that we follow in physics. Na? In chemistry, convention is different. Okay. In physics, we say if work done is positive, means system has done some work. If work done is negative, means we have done work on the system. Okay. Or all in all, you can say there will be net expansion. Okay. Net expansion. Here you can say net compression. Let's understand this. Okay. Then it will make more sense why I'm writing positive and negative. Okay. I'll erase this. Oh, I forgot to put the smiley. Okay, this is smiley. Okay, now let's understand why I've written positive and negative. Let's talk about first cyclic process. Let's talk about first clockwise. Clockwise की बात करते हैं. Pressure versus volume graph. ठीक है. So clockwise, suppose I started from A, I went to B, and back from B to A, like this. So I'm forming a cycle, and this cycle is clockwise. Okay, let's understand this. Suppose corresponding to A, here I have volume VA, corresponding to this I have volume VB. This graph, if I want to break this cycle, I can break this into two parts. Okay, I can make like this. First I am going from A to B. So I am going from A to B. Okay. Now if I ask you what is work done from A to B, so you will write work done from A to B, and that is nothing but area, right? Area under the PV graph. We know that area under PV graph gives me work done. Okay? So if you see from A to B, okay, let's say volume corresponding to A is VA, volume is VB. So I'm going from A to B, means my volume is increasing, right? You can see in this graph volume is increasing, right? So if volume is increasing, okay, I'll find this area. Let's say area is A1. Okay, now volume is increasing, means system is doing work. Expansion, volume is increasing. That means you can say there is expansion. If there is an expansion, you can say system is doing work. If system is doing work, means work done is positive. So you can say from A to B, area is, let's say A1, then you will add plus sign. Plus sign simply means system has done work. Simple. Now rest other half you can make it like this. Pressure versus volume graph. Okay, from B to A. Okay. Again, if I ask you what is work done from B to A. Okay, again you will find the area. So make a area. Volume VA, and this is VB. Okay, let's say this area is A2. Now if you see from B to A, B to A, B to A, my volume is decreasing. Okay, volume is decreasing means what? Compression. Compression means what? Work is done on system. Okay, if work is done on system, negative, right? So I'll write A2 with a minus sign. Now if I combine these two, if I ask you what is total work done, you will say work done from A to B plus work done from B to A. Now if you see magnitude wise, A1 is greater than A2. Graph में if you see area wise, A1 is greater than A2. Okay, so you have plus A1 and this is minus A2. Magnitude wise is this. So you can say overall some positive value. So total work done will be some positive value, right? So work done will be positive. Clear? समझ में आया? Logic is very simple. है ना? Now if you combine these two graph, you will get this graph only. है ना? इसीलिए work done total will be some positive value. Clear? Okay. Similarly, you can understand for anti-clockwise. Okay, I'll erase this. Okay, you have pressure versus volume graph. Okay. Okay, again I'll go in a cyclic process. A to B, A to B, then B to A. Now it's anti-clockwise. Okay. Again you can break this graph into two parts, same as clockwise to understand. Okay. इसको break करो in two parts. Pressure versus volume. I'm going from A to B. First A to B देखो, see from A to B. Corresponding to this volume BA, corresponding to this volume BB. Now if I ask you what is work done from A to B, है ना? Again you'll find this area. This area, let's say area is A1. Now if you see, I'm going from A to B, है ना? Volume expand कर रहा है. Volume is increasing, expansion, है ना? अगर ये expansion है, means system has done some work, है ना? So you can write work done from A to B, area A1 and with a plus sign. Clear? Means system has done work. System has done work. इसीलिए positive आया. Volume expansion. Rest half from B to A. Again break this. Pressure versus volume from B to A like this. Again if I want to find work done, okay, again I'll take the area, drop here, it's VA, drop here, it's VB. Find this area. Let's say this area is A2, है ना? So you'll write work done from B to A. Okay. Now if you see B to A, volume is decreasing, है ना? There is a drop in volume. Volume decreasing means what? Compression. Okay. Compression means what? We are doing work on system, right? We are doing work on system. Work is done on system. If work is done on system, work done we take it to be negative, है ना? So work done from B to A. Area is A2 and I'll add negative sign. ठीक है? Now if I ask you what is work done total, okay, if you combine these two, you will get back this graph, है ना? ये दोनों को add कर दो, you will get back this graph. So work done total, you will say work done from A to B plus work done from B to A, है ना? Plus A1 minus A2. So plus A1 minus A2. Now area wise if you see, A2 is greater than A1, right? So A2 greater than A1 है. Okay. So all in all this will be negative value. Okay. So total work done will be some negative value. ठीक है? The logic is clear. It's very simple to understand this. I hope you got it. Okay. Then we'll meet in the next class. Thank you.